Good morning, everyone, and welcome to the second day of the Math Summit third edition, proudly presented by S. Chan Publishing. I'm Preeti Kashyap, your host for this session, and it's a pleasure to have you all with us. Before we dive into today's session, I'd like to commend all of you for your continued enthusiasm and participation. Your dedication to enhancing math education is truly inspiring, and it's great to see such active involvement. Now, let me introduce our esteemed speaker for today, Mr. Shravan S K. Mr. Shravan holds a master's degree in computational and data sciences from Indian Institute of Science. He has a deep passion for school education and is particularly interested in solving puzzles and fostering inquiry-based learning. Since the beginning, Mr. Shravan has been a key contributor to the Seed2Sapling Education Foundation, which aims to make education more enriching and meaningful for both teachers and students. He was a part of Technical Secretariat for the National Steering Committee that developed the NCF 2022-23 and is currently working on the new NCERT Mathematics textbooks aligned with NEP 2020. In today's session, Mr. Shravan will guide us through the intricate process of selecting and using questions to build mathematical thinking. Participants, today is the day you have all been waiting for. After our last session today, starting at 4 p.m., we'll be having a quiz. The winners will walk away with Amazon vouchers worth rupees 50,000. So stay tuned for that. Before we start, here are a few housekeeping rules. Participants will be muted throughout the entire session. Please keep a notebook and pen handy to jot down any important points. The chat box will be enabled during the Q&A session or as required by the speaker. Remember to complete the feedback form sent to your email after the final session to receive your e-certificates. Don't forget to participate in today's quiz after the final session for a chance to win Amazon vouchers worth rupees 15,000. Now, without any further ado, let's begin this session. Please join me in welcoming Mr. Shravan. Sir, over to you.
Yeah, thank you. Hello all, namaste. Hope you have a good morning today. Let me share my screen. Tanisha, hope my screen is visible.
Yes, it's visible, sir.
Yeah, thank you. So today I'll be talking regarding how to choose and use questions to build mathematical thinking. Yeah, this is a very broad and in-depth topic. And today we have only 1 hour. So this will be giving a glimpse or an overview on what this is about. Okay, so we'll get started. So the session will be interactive. So to make the most out of it, I request you to participate with full involvement. So this is like, if this is like a sport, I want all of us to be players and not just audience or spectators. So dive in with full involvement and make the best experience out of it. So you can keep a sheet of paper and pen ready. So we'll also do some math, and also you can take some notes, whatever you find interesting. Okay. So here's a starter puzzle for you. So the question is, Tanu is traveling from Bangalore to Delhi, whereas Manu is traveling from Delhi to Bangalore. After a few hours of travel, they both cross paths and they meet. At this point, who is closer to Delhi, Tanu or Manu? So you can share your answers in the chat. I hope the chat is enabled. Okay. Okay. Nice to see the responses. So some are saying it's Tanu, some are saying it's Manu, and some say it is equal distance, depends on the speed. Okay. More information is needed. Okay. Information is not sufficient. Okay. Equal. Okay, fine. Yeah, so you can pause the chat for now. Yeah. So I hope all of you found what the answer is. So the answer is, if they are meeting at the same point, then they both will be at the same distance, isn't it? Neither of them will be farther or closer compared to the other. So both of them will be at a equal distance from Delhi, right? Okay. So yeah, this was just a starter. Since this is a math summit, I thought we'll also do some mathematics in the session. So, yeah. So let's go forward. So before going ahead, I wanted to hear from all of you what you think are the aims of mathematics education. So according to you, what are the aims of mathematics education? Again, you can share the responses in the chat. So before sharing, you can spend a few seconds thinking about it. You can take a minute, think about it, and then share it in the chat. So whatever your understanding is, or whatever your beliefs are about mathematics education, you can share those. Again, nice responses, diverse responses as well, making it relevant to daily life, life skills, conceptual, analytical reasoning and understanding, connecting the concepts, logical reasoning, estimating, problem solving, solve their daily life problems. Very nice responses. Maths is required in every field, basic needs. Okay. We can apply mathematics in our daily life. Okay. Interesting. Very nice. Okay. So, yeah, let's go ahead and see what mathematical thinking and problem solving means, right? Uh, so let's give this problem a try. So what I'll be doing right now is I'll be sharing with you a question, and I want you to take 2 minutes, yeah, at least 2 minutes to solve this problem. And only when I ask you to share the answer, you can share your answer in the chat. So till then, if the chat can please be disabled. Yeah, I'll show the question now. So the question is, Nambi writes numbers from 1 to 1000. How many times does the digit 7 appear? So take some time, solve, and you can share the answers after I ask you to share in the chat. Okay. Now you can share your responses. Yeah. Okay. 300 seems to be the majority of the responses. It's nice. There are other numbers as well. Okay. 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 Nice. So it was nice to see all of you solve this problem very enthusiastically and proactively. So the answer is 300. If what you have got is different, you can try it again later. So now we'll do a short reading. So all of you can open this link. You can either scan this QR code using a phone, or you can type this URL. And there is a short passage that I've selected from an essay. I will reveal what where the essay is from towards the end of the talk. So for now, you can just go to this link and take 5 minutes and read this. So you can open this link. You can either type this URL 128.pl slash E6HMG, or you can also scan this QR code. So there's a small reading. You can go through it, and whatever you find interesting or amusing in that reading, you can also make a note of it. Yeah, I'll share the link in the chat as well. Thank you. Yeah, thank you. So the link is also shared in the chat, so you can click on that. So while you read, if you find something interesting, please make a note of it. So if you are done reading, you can share what you found interesting about this in the chat. Any thoughts, any observations, any reflections based on this reading? It might be about the subject, the way it is taught. And many of you also mentioned what the aims of mathematics education are according to you. And how does this reading align with what you thought was? And also how mathematics teaching and learning happens in classrooms. You can share thoughts regarding these in the chat. Nice responses. You can also read each other's responses and yeah, get a different perspective. The idea of where to chop the line inside the rectangle. Okay. Provoking curiosity. The problem itself was very creative. The art is not about the truth, but explanation. Yeah, that's very nice. Right? Yeah. So many times we focus on the end product, but the process is ignored or neglected. Implementing art integration. Okay. Creating curiosity and mathematical thinking. Mathematics is about simple, elegant questions about our imaginary creations. Encourages children to think. Nice. The art of creating interest, intuitive thinking, about satisfying and beautiful explanations. Yes, math is not about memorizing the formula. That's nice. Okay. Very nice to hear these responses. So we'll go ahead. So I also wanted to show what the National Curriculum Framework 2005 said about the aims of mathematics education. Right? So they say the narrow aim of school mathematics is to develop useful capabilities, particularly those relating to numeracy numbers, number operations, measurements, decimals, and percentages. They say that the higher aim is to develop the child's resources to think and reason mathematically, to pursue assumptions to their logical conclusion, and to handle abstraction. They also say the ability and the attitude to formulate and solve problems is important. So yeah, from the talk, since the time the talk started, we have been talking about the aims of mathematics education or the importance of mathematical thinking and problem solving. But what exactly is mathematical thinking and problem solving? How do we identify if that is happening or not, right? So here I'll try to show some of the process skills and an exemplar listing of what it means. Right? So one is observing, where the student explores and finds patterns. Tinkering and questioning. So the child tinkers or plays with a mathematical phenomena, wonders and asks questions. For example, why something happens, or why not something? What if this happens? How is this happening? Conjecturing, making conjectures throughout the process, before, during, and after problem solving. So conjectures can arrive at any point of time. Right? Thinking and reasoning. So how a particular statement or a conjecture can be proved or disproved. What is the reasoning using inductive or deductive reasoning or logic? So one more important aspect is conceptual understanding, right? Whether the student has actually understood the concept and to what depth, right? Whether they are able to see the necessity or how it came about, and knowing how something works instead of just learning to do something, also knowing why it works. Right? Some more skills can be algebraic thinking. So in algebra, generally we directly jump to abstraction before giving them sufficient opportunity to exercise their algebraic thinking, which involves generalizing, formulating, using the patterns observed, and making small abstractions before going to the final symbolic manipulations. Right? Procedural fluency is also important. Ability to carry out a particular algorithm or a method without making any mistakes. And also visualization, visual thinking, solving problems visually, reasoning visually. Yeah. Also, many times, mathematics is not just a subject which is useful in real life, right? It is also done for deriving joy out of it. So many of you might also enjoy solving mathematics puzzles, right? It's like an art form. So as many people like hearing the music or playing an instrument or singing a song or dancing. So many of us also like solving math questions. So developing a subject appreciation for mathematics. And also communication. So in many times there is a single one-way communication in the classrooms, but the students don't get many opportunities to share their thinking, articulate their thoughts, and present their arguments, which is also very important part in developing the mathematical thinking and problem solving skills. And also perseverance. You might have seen this with yourself or with many students. The level of perseverance varies differently with different people and also at different times for us itself. So many times we don't want to know the answer from someone. We want to try it for some more time before asking for hints or assistance. So these are all some of the indicative process skills to be able to recognize whether mathematical thinking and problem solving is happening in our classrooms or not. So if we are more aware of these skills, then we can also be more aware of whether we are presenting students the opportunities to think and reason mathematically in the classrooms, right? Which are the aims of mathematics education, as many of you shared, and also as it is given in the National Curricular Framework, both in 2005 and the recent NCF 2023-24. Okay. So now we have talked about how mathematical thinking and problem solving is important. And we've also seen what could be some of the skills that constitute what mathematical thinking and problem solving is. But what questions tend themselves, give themselves these opportunities, whether all questions give such opportunities or whether there are only certain type of questions. So for example, if we take the question 3 by 4 plus 5 by 7 is equal to dash. So what are the different process skills that this question tends itself to? So you can share this in the chat. So my question is, if you choose a question like 3 by 4 plus 5 by 15, right? 5 by 16 is equal to dash. What are the different process skills that provide themselves, or what are the different process skills that are needed to solve this problem? So you can type your response in the chat. Is my voice audible?
You're audible, sir, but could you please place your mic a little closer to your mouth? So that
Okay.
sure.
Yeah, sure. Yeah. Thanks. So just before I showed you some process skills, right? I'll also show it again. So yeah, among these process skills, say observing, questioning, and conjecturing, mathematical thinking and reasoning, conceptual understanding, algebraic thinking, procedural fluency, visualization, subject appreciation, communication, perseverance. So the question, say adding two fractions, for example, 3 by 7, 3 by 4 plus 5 by 16. What are the different process skills that are needed to solve this problem? Okay, nice to see the different responses. Logical and thinking skill, adding unlike fractions. Okay, properties of LCM to make it like fractions. Okay, computational thinking skill, brainstorming, like fractions addition by conversion, conceptual understanding, all skills. Okay, interesting. Visualization, thinking and reasoning. Okay, procedural fluency. Okay, so if a child has solved this correctly, can we always say that they have understood the concept of fractions addition? Okay, no. Okay, there is a unanimous no. Interesting. So whoever is saying no, if you can also type why you think so. So my question is, if a child has solved this answer correctly, solved this question correctly, can we say that they have understood the concept? You can also share why you think so. Okay, they follow a fixed procedure without understanding why. Okay, because it could be that the child is just using an algorithm without understanding why. Okay. Yes, they may have understood the procedure, but may not understand why the parts have to be of the same size to count. Yes, very nice. It's perfect. Yeah. Questions is different with understanding. Yeah. So if you look at this question, to solve this successfully, the main thing you need to know is you need to know the procedure and carry it out without any mistakes, isn't it? So now let us compare this question with the question that we all solved initially. So which is how many sevens, how many times does the digit 7 appear from the numbers 1 to 1000? So I want you to just reflect back on how you solve the question. So how you solve the question? So the question is how many sevens appear between 1 to 1000? So how you solve that and identify the different process skills that arise during the process. And then you can share it in the chat. So look back at how you solve the question and try to identify the different process skills that you used during the time. Yeah, some of you might have joined a bit later. So initially, we all solved the question. That is, if we write the numbers from 1 to 1000, how many times does the digit 7 occur? So for this question, I'm asking you to reflect on how you solve the question and try to identify the different process skills involved. Okay, very nice. Finding patterns, conjecturing, generalizing, visualization, conjecturing, breaking down the question in simple groups in 1 digit, 2 digit, 3 digit, etc. Inductive method, finding pattern, observing, conjecturing, mathematical thinking and reasoning. Okay, interesting. Principle of counting method. Okay, nice. Making groups. Okay. Quite very much familiar with numbers, place values. Okay. Splitting the numbers into hundreds. Okay. So if we compare these two questions, in the first question, the students are taught a method, right? Yeah, either with or without understanding, and they're able to solve the problem. That is, they're carrying out the instructions given. Whereas in the other question, that is finding the number of sevens from 1 to 1000. So the question is a fresh question, and students are not taught any method, right? Okay. So the point of this slide was, for a question, so different questions have different kind of opportunities and possibilities with respect to process skills. So if we want to choose a particular question, so if we identify this, it will help us in making the decision whether we want a particular type of question or what fraction of questions like these do we want in our classrooms. It will make us more aware of identifying the different process skills a particular question provides itself. So whenever you solve a particular question, either in the different textbooks or if you are solving puzzles from different websites or books, whatever question you are coming across, after you solve, if you try to identify the different process skills, it will help us in becoming more aware of the different opportunities that it provides. So now, is just choosing a particular question sufficient, right? Or is there something more to it? So my question is it sufficient if we just choose the right questions? So will it be sufficient that these provide the opportunities of mathematical thinking and problem solving to students? Okay. Yeah, before going there, I also wanted to share with you some characteristics of what some nice problems can be. So we just saw that not all problems give themselves the different opportunities. So what are some characteristics of rich problems, right? So a good problem is something you don't know how to solve, right? So in the previous example also, this was a fresh question to many of you, that is identifying the number of sevens in 1 to 1000. So it was a fresh question and you initially didn't know how to solve, but you figured a way out, right? So a good problem is something you don't know how to solve. So the other characteristic is a good problem is one that when solved makes the solver wants to learn more. So many times you might have experienced this. So the problem itself teaches us something new and it wants us to solve some more problems like that, right? And the best problems are those that are both entertaining and challenging. So if we compare to the questions like say 3 by 4 plus 5 by 17, it's not very entertaining or challenging. Whereas when you see a question, there is an innate interest or a tendency that, okay, I want to know the answer for this. It should be entertaining and also challenging at the same time. So the best problems are the ones that teach you something while you solve them, right? So when you solve this question, finding sevens, you might have found out different patterns and new ways of counting. And once you have found out this, you can use this to solve any other related problems, right? So it can teach some new concept or a new way of thinking. So that also makes some problem a rich problem. And also the best problems are those that force you to rethink what you think you knew. So it might also many times break our misconceptions or limited understandings, right? So those also can be rich problems. So these characteristics I have identified and rephrased so different mathematicians. So I could not verify the sources exactly, so I did not mention the names. But these are coming from different essays or different reflections by famous mathematicians or mathematics educators, right? Now coming back to the question, is choosing a particular question sufficient, right? Just choosing rich problems, is it sufficient? So for example, we have this question, how many sevens are there from 1 till 1000? Say teacher A presents this problem in the class, right? Gives sufficient time for students to explore, find patterns, and solve on their own, right? And as you might have observed, this problem has different ways to solve. There is no one single approach. There are multiple ways to solve. So different students might think differently, and they might solve it. So the teacher A has presented the problem, has given time for students to explore, think, and solve it on their own. So I'll compare it with teacher B. So what the teacher B does is, the teacher B presents this problem and starts explaining how to solve this problem. Say, for example, so the teacher has presented this problem, and the teacher starts by saying, okay, now let us list how many sevens appear from 1 to 100. How many sevens does 1 to 100 have? Okay, if you look at it, 7, 17, 27. So all this till 97, there are 10 sevens in the units place. And there are 10 sevens in the tens place from 70, 71, 72 till 79. So how many sevens occur from 1 to 100? We have 20 sevens. Now, the same will happen from 100 to 200, 200 to 300, and so on till 1000, right? So how many sevens do we have in tens and units place? 20 in each 100, so 200. Now there is also hundreds place to look at it. So 7 occurs in the hundreds place from 700 to 799. So there are again 100 times the 7 is appearing. So totally it is 300 times. So here the teacher B has explained, right? Has explained the solution or explained the method to teach, where the opportunity, so there is no mathematical thinking or problem solving happening at the students level. So they're just receiving or they're learning how to solve. So the point I'm trying to make is there are two aspects to this. One is choosing the right question or choosing rich problems. So it is not sufficient if we just choose rich problems, but we should also try to give students the opportunity to think, explore, discuss, and present their own solutions, right? Giving time is very crucial. Yeah. Now, where to find such questions, right? So that is the question. So you might have observed this in even in NCERT textbooks. There are labels like think and discuss, explore, try this in many questions. So these many times, if you notice, these are questions which tend themselves to critical thinking and problem solving. So there are also several books, websites, and blogs. So a couple of websites I have listed here. Say, for example, enrich.com or mathingon.org. So you can find questions here. And as I was saying, it is very important for students that time is given for them to explore, think, and solve. So it is the same for us also. So if you remember, when I presented the question, I gave 2 minutes time and only then ask responses from you. So if we are presented with a new problem that we don't know how to solve, I think all of us agree that we all need time to think and solve, isn't it? So unless we provide students time, yeah, there is not much mathematical thinking or problem solving that is happening in the classrooms. And more importantly, we should create a judgment-free space, or what we call a mistake-friendly classroom, right? So unless the fear of learning, the fear of making mistakes is gone, so there is no willingness to learn. So there is always anxiety and fear. It is true for us also, right? Whenever we want to learn something new, we are bound to make mistakes in the process, and it is perfectly fine. It is part of the learning process. So if we start labeling students or scolding students if they make mistakes, then they'll start fearing the subject itself. So creating a safe space for discussion and presenting the responses without the fear of being wrong is also very important. And also having classroom discussions, right? So today, due to the limitations of the format of this session, I could not ask how each of you solved the question. But if I had asked, I would have got multiple ways of how each of you might have solved. So in a classroom, it is very important for students to get exposure to these multiple ways of thinking, and also that there is no single way to solve. So there's a common misconception or misunderstanding in many students that mathematics means a particular way of doing things always. So which also can be broken if we have regular classroom discussions. Yeah. And some small things that you can do is whenever you start a new topic or chapter, instead of announcing the chapter name, you can start with a related rich question, right? And then go into the chapter. So this also helps them to approach a problem fresh. So many times what happens is, if you have noticed, in each chapter there will be some exercise questions, and the exercise questions are directly related to the concept that was presented before. So many times there is no the need itself is not there to understand what the question is asking. So blindly we just apply what is presented before, isn't it? So if we present fresh questions to students, so that will remove this bias, or remove this blind solving or blind applying methods, applying the methods blindly. So you can also try this, giving questions from different chapters throughout the year, instead of presenting only the questions related to a particular chapter, so that students always think fresh and try to understand the question before going ahead, right? And also including sufficient number of rich questions in summative assessments, be it your regular unit tests or midterm and final exams. You can also include this type of questions which tend themselves to the aims of mathematical thinking and reasoning and problem solving. So unless we include such questions, the focus in the classroom, either by the teacher or the student, the focus will not be there so much. You might have also noticed that the kind of questions that we put in assessments also drives the day-to-day teaching learning process. So if you change the assessments, the type of questions and assessments, it is also very easy to change the regular math classroom pedagogy. Yeah. So yeah, we are at the end of the session. So I would like to quickly go through what we did in the session today. So initially we saw what is mathematical thinking and problem solving, right? And yeah, in the reading also, you saw the distinction between just following a procedure and original problem solving, right? And I also showed you the different process skills, right, from observing patterns, algebraic thinking, or visualization. So the different process skills associated with the mathematical thinking and problem solving. And once we are aware of the different process skills, now choosing questions which have more opportunities associated with the problem skills, with the different process skills, right? So the choice of questions itself is very important. And along with the choice of questions, we also saw that how the teacher takes it in the classroom becomes equally important, right? So if we just, even if we choose rich questions, but if we don't give students opportunities to solve it on their own, then we have not done any better. Yeah, I want you to pause again for a couple of minutes, write down reflections from this session and whatever you found interesting. So you can take a couple of minutes time, just again go through the summary. What struck you from this session? What are your takeaways? What you found interesting? You can write down and then share it in the chat. Yeah, I forgot to mention the source of the PDF, the passage that you all read. So it is taken from a essay called A Mathematician's Lament, written by Paul Lockhart. I recommend all of you to read it sometime. You'll find it very interesting. So I'll also type it in the chat. So if you just Google this, you'll find a free PDF and you can read it whenever you get time. Yeah, you can also type in chat what you would like to change going forward in your classrooms or whatever, however you are associated with mathematics education. What are some things that you would like to change going forward based on this session?
Right. And also you can write in your questions, or if you have any queries regarding this session, you can type in the chat box and Mr. Shravan will be happy to address them.
Yeah, thank you.
Ms. Prerna has asked, tell some good resource websites if you have, you can share that.
Yeah. So enrich.com has a very good compilation of very rich problems across grades. So starting from primary grades till high school. So they have very good collection of puzzles and questions like this. And also mathingon.org, right? So that is also a good source of finding such questions.
Audience, if you have any questions, you can type in the chat box. Okay, there's a question. Please suggest some good books related to the math teaching.
Good books related to math teaching. Yeah, one is the essay that I had shared with you. That is the A Mathematician's Lament by Paul Lockhart. So that's a recommended read. And there are also some books books called Mathematician's Delight by W. Sawyer. So that is also a nice read for you to go through. Yeah, A Mathematician's Delight by Sawyer. You can search Mathematician's Delight, you'll get it. I'll also type it in the chat.
Okay, so we have a question. Primary children focused word problems, how to solve that?
Huh. Yeah, word problems is a common complaint across grades, across schools, and even across countries. It's like a universal problem. So at least in India, I think if we look at word problems, one is the initial barrier itself is comprehension, right? So many times students blindly, without trying to understand what the question is, they try to identify what operation they have to use, right? So for example, if they see the word together in a question, they simply try to add the two numbers presented. So the initial barrier is making the students understand the question, right, before trying to solve. I think that itself solves many of the problems. So you might have observed this many times. The students are solving, say, abstract questions like 45 plus 63. But the same thing when put in a word problem, if they're not able to solve, then the issue is of comprehension. So here you can either try to use the language which the child is comfortable, right? Instead of always being focused on communicating in English. So that should not have precedence over understanding. So the understanding is important. So if it means using the child's mother tongue or even being bilingual, so please do that and try to make the child understand what the question is. So that itself should solve many of the problems. So even after that, if they are not able to solve, then again, you should try to see where the child is, right? Try to go a few steps back or present some simpler problems, right? Present a simpler version of the same problem and try to see if they're able to solve it. So I think, yeah, you can do things like this to see.
So there's one more question. How to create questions based on competency?
How to create questions based on competency? Yeah, good question. So again, as we saw in today's session, right? So the first thing is, given a question, we should be able to identify what the different competencies are. And much later, and this we ourselves should do for a different variety of questions. Different variety of questions in terms of difficulty and also cutting across concepts and across grades. So as teachers, if we try to, whenever we look at a question, as we did today, we did this for two questions, right? One was the fraction addition question and also the initial question that I gave of how many digits are there. So whenever you come across any question, just try to identify what are the different learning opportunities or the competencies that are present in the question. And the more and more you do it, so the more you will be aware and start finding questions at different places outside before trying to create questions on your own. So over time, you can build this ability to make questions related to a particular competency. So creating questions is not always very easy. So the more you do it, it comes naturally to you. Yeah, yeah. Shankar has shared some more good books. Yeah, how to solve it using George Polya. Yeah, that's wonderful. And also Joe Bowler. Yes, they also share some very interesting resources. You can also go through that. Yeah.
Miss Anita has asked, we want to give sufficient time to explore the students, but we are having time limit to complete the syllabus. So how can we resolve this problem?
Yeah, that's a very valid constraint, right? We always have this syllabus constraint, and also the diversity of classroom is also many times a challenge. So we can also try to balance. So instead of always doing questions, straightforward questions, which require just following procedures, you can try to maintain a good balance, right? So for example, if I ask a question, right? If I ask a question, which two numbers add to give the number 100, right? Which two numbers sum gives 100. So in the process of solving this, the child would have done several additions compared to a question 40 plus 60 is equal to dash. So isn't it? So many times the choice of questions, with a single question, we can make them do more math. So the choice of questions is also very important. So even by doing few questions, they would have done much more mathematical thinking and problem solving. So the choice of questions, again, and trying to maintain some balance, and also trying to give, so if we give interesting questions, even if we don't impose it on the students, they'll solve it even beyond the classroom time, right? So the question should be interesting. So if the question is interesting, even if you put it at the end of the session, many students who are interested, they might do it on their own in their free time, taking extra time on. Whereas if we give boring questions, then we'll have to make it compulsory and yeah, like, so yeah, the choice of questions and how we do it can also play a slight role. And you can also try to optimize in certain repetitions. So many times we teach the same concepts across years. So you can make some optimizations there, cut down some things here and there, and make space for the same. And try out some of these.
Right. Thank you so much, Mr. Shravan, for delivering such a thought-provoking session.
Thank you.
Your insights into the role of questions in building mathematical thinking have been incredibly valuable, and I'm sure everyone here has gained new perspectives. A big thank you to all our participants for your active engagement and thoughtful questions. Your commitment to enhancing math education is commendable, and we hope you have found the session as enlightening as we did. This concludes this session. Remember, we have more exciting sessions lined up today. Also, don't forget to participate in the quiz after the final session today for a chance to win Amazon vouchers worth rupees 50,000. Thank you once again, sir. Thank you, everyone, for joining us. Keep up the great work, and we look forward to seeing you in the next session. Until then, continue to inspire and support the young learners in our lives. Thank you. Thank you so much, everyone.
Thank you.